Good morning, friends. We are studying problems related with the torsions. So please try to understand carefully problems related with the torsions. So because we are conducting surprise test that is based on the torsions that I will announce, or I will give the message in the WhatsApp group. So in the next weeks, probably in the next weeks, I will conduct a surprise test that is based on the only one chapter. This is the torsions. So be prepared for the torsions. What is polar moment of inertia for shaft? What is torque equation, and what are the assumptions that is to be considered during the torsion, and some of the theory. So that I will explain in the during the this online lectures. So please try to note down today's first problem. A solid circular shaft transmit 75 kilowatt at 200 rpm. Calculate the shaft diameter. If twist in the shaft is not to exceed 1 degree in 2 meters of shaft, and the shearing stress is limited to 50 Newton per mm square. Take C equal to 1 into 10 to the power 5 Newton per mm square. So first, as per the given data, extract given. So try to write given data. 75 kilowatt power, 200 rpm, theta equal to 1 degree, length 2 meter, tau equal to 50 Newton per mm square, and C equal to so first we will calculate the torque. As you know, P equal to formula 2 pi nt divided by 60 into 10 to the power 6. So that's why T equal to 60 into 10 to the power 6 multiplied by P divided by 2 pi N. So here's this P in kilowatt. So that's why 75 is 2 pi RPM equal to N 200. T equal to 60 into 10 to the power 6 multiplied by 75 divided by 2 pi, and this is equal to 3.58 10 to the power 6 Newton mm. 58. Suppose this is 1. Now, as per consideration of strength, here two diameter means two condition given, because this basic formula tau divided to T divided by polar moment of inertia, tau divided by R's equal to C theta divided by L's. So this is the shear strength equation, and if this is, we are using, this is sorry if this is shear stress equation, and if this is considered, this is considerations of stiffness, because angle of twist means stiffness. So that's why by using first relations, T divided by polar moment of inertia equal to tau divided by R's. So T equal to 3.581 into 10 to the power 6 divided by pi by 32. This is polar moment of inertia means pi by 32. This is solid 2 diameter, that is to be calculated. So that's why d raised to 4 equal to tau equal to 50, and this is R equal to D. So this is ratio equal to, so this is also ratio, so that is polar moduli, and we will see that what ratios is called. Now, so this is D cube equal to, because 1D will get cancelled and this is goes in the right hand side. So this is 35.81 into 10 to the power 6 multiplied by 32 divided by pi into 50. Divided by pi, and this is cube under root. So D equal to 90.02 mm. Now, as per considerations of stiffness, T T divided by polar moment of inertia equal to, this is C theta divided by L. 6.81 into 10 to the power 6 5 by 32 d raised to 4. C equal to 1 into 10 to the power 5 and theta equal to angle of twist. This is we requires in radian, so that's why multiplied by pi divided by 180. So this becomes radians because calculation purpose we requires this is in radian. L equal to length equal to 2 meters. So convert this is in terms of mm. Now d raised to 4 equal to 6.581 into 10 to the power 6 multiplied by 2000 multiplied by this 32 divided by this pi divided by 10 to the power 5, and this 180 goes in the numerators, and in the denominators again divided by 10 to the power 5. 6.581 into 10 to the power 6 multiplied by 2000 multiplied by 32 multiplied by 180 divided by pi divided by pi. This is equal to D equal to 93.61 mm. So that's why we can select diameter of the, because higher diameter that is to be select. So diameter of the shaft approximately we can increase, this is 95 mm. Why this is? Because for round of this, otherwise or 93.61 mm. So this is your expected answer. So note down next problems. A hollow shaft is to have an outside diameter. This is today's second problem. A hollow shaft is to have an outside diameter D and inside diameter D by 2. Calculate the minimum value of D if it is to transmit, if it is to transmit 375 kilowatt at 105 RPM. So this may be output shaft of the gearbox with a working stress of 40 Newton per mm squares. Determine the twist. Determine the twist in a length of equal to 10 times the external diameter. Take C equal to 8 into 10 to the power 4 Newton per mm square. So in the previous problem, both relation is to be used. In this problem, I think only one relation. So what is given, that first extract diameter. So this is inside diameter, outside diameter, d by 2. 375 kilowatt, 105 RPM, 40. Length C, 8 into 10 to the power 5, and this is given. So first step is the calculate torque. So torque equal to 60 into 10 to the power 6 multiplied by P divided by 2 pi n, and this 60 into 10 to the power 6, P equal to 375 kilowatt, RPM equal to 105. So more torque is to be transmitted, so that's why we'll get more torque, that is to be transmitted. 60 into 10 to the power 6 multiplied by 375 divided by 2 divided by pi divided by 105 equal to 34.104 into 10 to the power 6. So again we have to use, this is what is to be calculated with the working stress of 40 Newton per mm square. Determine the twist in a length. So first design up of the diameters. So again we have to use these relations C theta L's. So polar moment of inertia equal to IP equal to pi by 32 d raised to 4. Alright. So by using
T divided by polar moment of inertia equal to tau divided by Rs. T equal to 34.104 10 to the power 6 pi by 32. Okay. So here's, this is inside diameter. D by 2 raised to 4. So this relations given, pi by 32 d raised to 4, and this is d raised to 4 divided by 16. Or this is, by taking LCM, 16 d raised to 4, and this is d raised to 4. So that's why this is 1d will get cancelled, pi by 32. This is 15 d raised to 4 divided by 16 equal to tau equal to 40, and this d equal to d by 2, radius equal to, this radius equal to outer diameter divided by 2. So that's why this d will go in that side, d raised to 4 divided by d by 2. Now this is in the left hand side, 10 to the power 6 multiplied by 32 multiplied by 16 divided by pi into 15 into 40. Right? Cross multiplication. Likewise, 5, 32, 16, right? 32, 16 divided by pi into 15, and this is 40, right? So this 1d will get cancelled, d cube equal to 32 into 16 divided by pi into 15 into 40, and this half goes in the right hand side, multiplied by 10 to the power 6 multiplied by 32 multiplied by 16 divided by 2 divided by 15 divided by 40 divided by pi So once again I will check, because I am not getting correct value. .68 d equal to, I will check my answer. Right. So that's why length equal to 10 times d. So this becomes 0.8 mm, 10 times. Now so this is first bit. Second bit, angle of twist. So angle of twist, again we have to consider this is, because this is given, c theta divided by n, t equal to 34.104 104 pi by 32. Now we have to consider that diameter 166.68 divided by half of is means 68 divided by 2 bracket square. C equal to angle of modulus of rigidity 8 into 10 to the power 4 theta equal to, that is to be calculate length equal to so theta equal to 34.104 into 10 to the power 6 multiplied by 32 divided by pi. So this is 68 and this is 83.34 raised to 4. So first we will calculate that this denominator value 83.34 multiplied by pi 1 divided by answers 34.104 into 10 to the power 6 multiplied by 32. So we are making any mistake? Yes, and divided by 8 into 10 to the power 4. So this is 9.99 into 10 to the power minus 3, and if this is multiplied by, so this is in radian, and if this is values 10 to the power minus 3 multiplied by 180 divided by pi, so this is in degree. So angle of twist 0.572 degree. Right. So please note down next problem. A solid shaft of (200 mm) diameter has the same cross sections area as the same cross sections area as that of hollow shaft. Of the same material, means material same of the same material with inside diameter of inside diameter of 150 mm. Find the ratio of power transmitted by the two shaft at the same speed and second bit angle of twist. Find the ratio of the. So this is also second bit. Angle of twist in equal length of these shaft when it stressed at the same intensity. Right. So here's the ratio of the power which is to be transmitted and the ratio of the angle of twist of the hollow shaft and angle of twist of the solid shaft that is to be calculated. So first we can consider, so here's 200 mm diameters has the cross section. So solid shaft. So because of the cross sections area of solid shaft equal to cross sections area of hollow shaft. So first we'll see what relations we'll get. A solid shaft 200 mm. So this area equal to 5 by 4 200 square into pi by 4 d square minus 150 square, right, with inside diameter of the 150 mm. And this will get cancelled. So d square minus, this is 225 0 0 equal to, this is 40,000, d equal to d equal to under root one 65.83 mm. So here now first bit, the ratio of power transmitted. So yes, we have to use T divided by polar moment of inertia equal to tau divided by R. So for solid shaft, this is tau into IP divided by R. So this tau IP pi by 32 raised to d raised to 4, and this I is d by 2. You will get this is pi by 32, sorry, this is 16, this is d cube. And similarly for solid shaft, so for hollow shaft, this is T, polar moment of inertia. Okay, this is T. Again tau equal to pi by 32. So in this case, so here's this is tau and this d equal to I think 200 cube. Now here so what we calculated that is correct. Oh, so actual this is equal to 40,000 plus this is 62,500. This is equal to 250 mm. Here's capital D raised to 4, small d raised to 4 divided by d by 2. Again this is pi by 16 into this is 250 raised to 4 d, small d equal to 150 raised to 4 and this d equal to 250. Suppose this is first equation and this is second equation. For now, because here this ask ratio is the, so we'll calculate a ratio of power transmitted equal to T hollow shaft divided by T solid shaft. Hollow shaft tau multiplied by pi by 16, 250 okay. Sorry, this is divided by 250 and this is 200 cube. So this will get cancelled. So what is remaining? 250 raised to 4, 150 raised to 4 divided by 200 cube into 250.
square minus 150 divided by 200 cube divided by 250. So this ratio equal to 1.7. Power means power transmitted by the hollow shaft is more as compared to the power transmitted by the solid shaft by using the same material and having inside diameter is equal to 150 mm. Now next, ratio of angle of twist. So relations T divided by polar moment of inertia equal to C theta divided by L. So this is for solid equal to T solid, L solid, solid, solid. So T solid, same torque. Same intensity. So we have to consider these relations. Second relation. This relation is to be considered because at the same intensity. So that's why here C into R divided by tau multiplied by L divided by C into R. Length equal to length, having same length, only here's R equal to for solid, this is 200 divided by 2 means, and for hollow shaft again this is same, but this is tau into L, C into, here's capital R equal to, this is small r, this is capital R. So here's 250 divided by 2. Now this ratio equal to tau into L divided by, so this is hollow divided by solid. C into 125 100. Sorry. So this will get cancelled, and this is, so angle of twist also less above the hollow shaft. 100 divided by 125 means 0.8. So this ratio also small, means angle of twist also less. So this problem is the
third problem. Now we will solve, or we will see fourth problem in the, and this is the last problem sum of the today's class. So be prepared for surprise test, which is held in the probably in the next week, and that is based on the these chapters only, torsion. So please note down today's fourth problems. Find the diameter of shaft required to (60 kilowatt) at 150 rpm if the maximum torque is likely to exceed the mean torque by 25% for a maximum permissible shear stress, for maximum permissible shear stress of 60 Newton per m squares. Find also the angle of twist. Find also the angle of twist for a length of 2.5 meter. Take C equal to 8 10 to the power 5 Newton per m squares. So here given data 60 kilowatt, RPM 150, maximum torque equal to 25%. So this is 125% of the mean torque. So why this is 125%, means 125%? Because this is equal 1% and that is the additional 0.25, 25% means. So that's why this becomes 1.25 times mean torque. Sorry, this is T. Shear stress equal to length equal to C equal to right? So what is to be calculated? Find the angle of twist, find the diameter. So first, diameter of shaft. So this is the based on the strength. So yes, use T divided by polar moment of inertia, tau divided by Rs equal to C theta divided by Ls. Mean torque by 25%. So we have to consider these relations based on the shear stress, means this is the stiffness. Now T equal to, can I directly write 60 into 10 to the power 6 multiplied by P divided by 2 pi n. 60 into 10 to the power 6 multiplied by P equal to, okay, this is 60 kilowatt and divided by 2 pi RPM is equal to 150. So this is mean torque. Sixty into 10 to the power 6 multiplied by 60 divided by 2, multiplied by 60 divided by 2 divided by pi divided by 150, and this is equal to 3.819 into 10 to the power 6 Newton mm. But this is T max equal to 1.25 times T mean. So that's why multiplied by 1.25. So this is 4.774 10 to the power 6. Now by using relations, T max divided by pi by 32. This is hollow, solid. D raised to 4 D divided by 2. So tau equal to, tau equal to 16T divided by pi d cube, and cross multiplications means d cube equal to 16T or d equal to cube under root. So this is popular formula. This relations is the popular for solid. T divided by pi into tau. 4.77 into 10 to the power 6 pi, and this is 60. D equal to, this is equal to 74 mm. D equal to 74 mm diameter. Angle of twist for a length of, now T divided by polar moment of inertia C theta divided by L. So this is 4.77 10 to the power 6 pi by 32 raised to 74 raised to 4. C equal to, so we require C, 8 into 10 to the power 4 angle of twist, length equal to 250. So theta equal to multiplied by 32 2500 divided by pi 74 raised to 4 8 into 10 raised to 4. So this is in radian. First find out this. .77 into 10 to the power 6 multiplied by 32 multiplied by 2500 divided by pi divided by 74 divided by 8 divided by 10 to the power 4. So this 0.045 radians, and in terms of the degree means multiplied by 180 divided by pi. This is equal to 2.9 degree. So due to limitations of the times, today I stop here and we will continue remaining portions that is related with the torsions in the next class. So can I stop here? Thank you.